So, but I do need to go over this for you guys real quick. This is the sine of u, 3 pi over 4, and the cosine of v, which is negative 5 pi over 13. Now, there is a couple things to know about this. First of all, is our angle going to intersect the unit circle? Are we going to have a point that's on the unit circle? No. So we obviously know that I keep on repeating myself over and over. When you don't have a point that's on the unit circle, you have to create a triangle, right? But the issue becomes is we have to be careful when creating a triangle, because now we also have a constraint. And the constraint says you have to create a triangle that is only in quadrant 2. So this, which a lot of you always want to do, right? You guys say, oh, well, I'm always just going to create this triangle. I'm always going to create this triangle. Now we have to create two triangles that are in quadrant 2. All right? So we look at this and we say, well, how are we going to create your triangle? Well, remember, guys, when creating your triangles, we always have them, right, as a perpendicular to our x-axis, and then having a straight arrow to our vertex, which we call our central angle. I'll call that u, and I'll call this one v. Okay? Now, remember, cosine represents adjacent over hypotenuse. Adjacent is negative 5 over 13, which is your hypotenuse. So that's negative 13. I'm sorry, that's negative 5 over my hypotenuse. Sine, remember, is opposite over hypotenuse. So that's 3 over 4. So notice, all right, now let's look into the sine formula. It's asking us to find, what is it asking us to do? The first problem I was going to do is sine of u plus v. Sorry. So the question actually is sine of u plus v. So to do a sine plus v, u plus v, you have to use your formula, which would be the sine of u times the cosine of v plus cosine of u times the sine of v. Now, this one gets a little troubling because, hey, I know the cosine of u, right? Or I'm sorry, that's the sine. I know the sine of u. But guess what? I need to figure out the sine of v. So that means I need to figure out the sine here. Well, right now, I don't know this opposite, right? I'll maybe call this b, and I'll call this one c, or a. I don't know this value, right? I don't know that value, but I'm going to need them to evaluate. Now, thankfully, this is a Pythagorean triple, so you guys should know that b equals 12, right? This one is not a Pythagorean triple, so I'll do 4 squared. 4 squared equals 3 squared plus a squared. Yep. Remembering your triples from geometry class? 3, 4, 5. Huh? 5, 12, 13? No? Yeah, absolutely. Do a Pythagorean theorem. Watch. 13 squared plus, 13 squared equals 12 squared plus negative 5 squared. 13 squared, 169, equals 144 plus 25. Oh, that was, so you guys can see that obviously works, right? That was supposed to be b. But anyways, here I have 16 equals 9 plus a squared. Subtract 9, 7 equals a squared. A equals the square root of 7, which the first 5 digits is 2.6457513, FYI. So we got that. Now to evaluate this, the sine of u. So we go to our angle u. Sine of u we know is 3 pi over 4. The cosine of v, negative 5 over 13. Plus. What? Okay. Plus the cosine of u. So now we go up to here. The cosine is adjacent over hypotenuse, square root of 7 over 4. And the sine of v is 12 over 13. Okay? So therefore, we now have negative 15 And I think you could factor out a 3 up top, right? And you could factor out a 52. So when I factor that out, I have, yes? Right. So in this one, if I take out a 3, I'll take out positive 3. I'll have a negative 5 plus 4. Right? Okay? That's it. So you guys have done a great job listening to me throughout this whole class. I know you guys wanted me to go over some examples.